Hello everyone, today we will perform
AC voltage controller using ACR. We will connect to ACR in anti-parallel and finally we will get this output. So let's start how we have made this connection. We will see that.
so before we do the connection on the real kit, we perform the experiment on the real. Let us make the connection here so that it will be very easier for you to understand. At the same time, you will not make any mistake on the kit and which might damage the kit. So since the objective is to make AC voltage controller, this means you will control the output of the light, and to control the output of the light you will control the voltage across this bulb, right? So let us take this from AC supply a phase and connect it to the this ACR, or either you can connect to this ACR, but let us assume for this instant it has a positive half cycle, and so if I connect it here, it will be forward based if I uh, put a appropriate gate pulse across the gate and cathode, right? So let me connect it here, and just I assume that I have provided the appropriate gate pulse, so the supply will come here and I will feed this to the bulb one terminal, and bulb next terminal will be connected to the neutral of this AC supply. And now what will happen? Bulb will glow. Bulb will keep glowing till the it get the output. Just assume we have provided the pulse here, and it will you will get the output up to here, because after that it will thus, since it is a supply is sinusoidal, it will cross through zero, and when it will cross zero it will go to the negative side, and at that time this will become reverse biased. Now but I want the output at the negative side also. So what I will do, I will connect this wire again to the negative of this ACR, and again I will fire at the my required time when whatever I like. And for example, I have fired provided the gate pulse at this time, and so I will get a output in the negative direction like this, right? You can make it like this, right? And so, and again at the same time, since I will connect this to this wire, right? Because neutral is already connected, and this output, this supply will come through this. So again the bulb will glow for this period, and since this will be in millisecond, you will not see the blinking of the bulb. You will feel like it is continuously glowing, but the output will be lower. Okay, the light output will be lower, it will go down. Okay, so this is the whole circuit that we will make on the kit. So again, if you want to see the output, you will connect the DSO one channel terminal here, another here. Again, if you want to see the sinusoidal input, you will see here. If you want to see the gate pulse, you will connect here and here. If you want to see the voltage across the here, you connect here and here, right? So these are the waveform that we should get when we will see the output or input, whatever, in the DSO. Okay, so this is the first waveform. You can see is the input sinusoidal waveform, and this wave is the current, load current, right? And this is the input sinusoidal wave. You can see this also, we'll see this, and these are the pulses. So here we have fired the ACR, this is just one ACR, and here we have fired the another ACR. So when you will fire, this means we have made on the one ACR, and here it has been reverse biased. Again at this time we have given the pulses to the gate of the another ACR. Again this ACR has become on, and we have get output. So we are getting the output for both positive and negative side also, right? Because we want to keep the output AC, not DC, right? That's why we want, we have fired and we have connected two ACR so that we can get the positive and negative both, and in anti-parallel. That's why we have connected. And this is the waveform across the ACR. If you will connect one of the channel across the ACR, you will get this, right? When the ACR will be off, you will get a voltage. When the ACR will be off, you will get the voltage. For this person the ACR is on, and for this person this ACR is on. So you will see this. Yes, we have not connected this waveform across the ACR channel across the ACR, so we will not see this in the DSO, and also this, but we will see this and this waveform.
So this is the AC supply, this is the live, and this is the neutral. So I will connect this wire in this live and take any of this ACR. let's take this, and I will connect this to the anode side, and at this SCR across this I will connect another SCR with anti-parallel to this. So to connect the another SCR, what we will do that I will take this cathode and connect to the anode of this SCR, and again connect this anode to the cathode of this SCR. It will be anti-parallel, and so this way it will be made. This anode will be connected to this cathode, and this anode will be connected to this cathode. Okay, this SCR is anti-parallel to this. If you observe it, you will find that. So after that I will take this AC supply, a single phase AC supply that is live have come here. After it will pass through this SCR, and I will take from here another terminal of this SCR, or you can say this SCR, because they are connected in anti-parallel, and from this cathode I will take it to the live of this bulb. It is another terminal of this bulb, and neutral of this bulb will be connected to the supply. So I will connect this neutral to the supply, and this is the overall circuit, the most simple circuit, and it is completed. The bulb should now glow. If I will make the circuit on, it should glow, and let me check it. And you can see, and if you vary this conduction angle, the output of this bulb should go down, and you can see here. And so finally we have to see the wave from output wave from across this DSO. So I will connect one of the channel of this DSO to the output of the bulb that is across this. So I will take this and put it here, and you can see we have got this output in the DSO. That it is the overall output. You can see in the positive half cycle also there is some firing angle, in the negative cycle also, because we have connected two SCR in anti-parallel, and both the SCR are fired at a particular firing angle. And if we will vary, both the firing angle will vary. You can observe it. You can see the firing angle is increasing, and so the output of the valve is going down, right? And if you will increase the or decrease the firing angle, the average output will increase, and you can see here. We can see the output voltage, magnitude of output voltage across this analog voltmeter. So I will connect this to the bulb, across the bulb, and since this is a AC voltmeter, you don't need to worry about this positive or negative. You can connect any terminal anywhere, and you can see we are getting something voltage like 115 volt, but actually it is not 115 volt, because it is connected across 300 and the scale is of 150, so it will be multiplied and it will be something like 230 volt. So the maximum voltage we are getting is 230 volt, and in this way if you decrease this conduction angle or increase the firing angle, the output will decrease. You can see here. I am increasing the firing angle, and you can see the output voltage has decreased. It is 180, and we can decrease more. Almost 50, that is 100 volt. So this was the AC voltage controller, and in this way you can make AC voltage controller. I hope you have understand.
So thank you everyone. In this way you can perform this experiment, and hope this video was useful.